Okay, so these are the little units I was talking about, which is an Arduino Uno with a prototyping board on the top to make it easier to plug together little bits of circuits. You've got access to all the Arduino pins around the side of it, and then there's this area where you can make your own little circuits up. So that said, we will build up a example circuit looking at the DC case. So we'll start with a resistor at the top, like that, and we'll feed this from 5 volts. And then at the other side of the resistor, we'll take it to ground through a capacitor. Here we go, capacitor to ground. There's a ground connection here, and we'll monitor the voltage using the Arduino through this cable at the junction between the two. And we'll start off with the capacitor short-circuited. I'm just going to short-circuit it with this lead here, so that initially the capacitor starts discharged. Okay, can we zoom in a bit on that? Okay. So, over to the software. So, we will take readings from the Arduino every time interval. Now, the Arduino has a 10-bit analog to digital converter in it, and so it will come up with a number between 0 and 1023 as the reading, and we can convert that into a voltage simply by multiplying by 5, because it's a 5-volt supply, and dividing by 1023. So we'll do that here, and so we'll say the second column is the first column times 5 divided by 1023. Okay. We'll read from the Arduino, connect it up, check that it's reading. It is, so we'll clear that. So let's start taking some readings. Initially it will be 0 because the capacitor is short-circuited to ground. So if we remove the shorting link, the capacitor will start to charge through the resistor. You'll see the values start to rise. And so if we now connect the capacitor to if we now connect the resistor, instead of connect it to the positive supply, we connect it to a ground connection. It will now start to discharge in the same way. So that's the DC case. Okay, this time I'll think of a demonstration involving looking at an AC measurement. So similarly, we have the breadboard here. We've got a resistor capacitor pair. I've changed the values from before to make the time constant more useful. But instead of feeding the input to the filter from a DC, we're going to feed it via this isolation transformer from the audio output on the computer. So we'll be able to generate sine waves of various frequencies from the audio output and see how the filter responds. So we can set the frequency to 70 Hertz and take a reading. There we are. That should give us 1 point on the graph. So we're plotting on a logarithmic scale this time for frequency. So if we increase the frequency and take a data point, and we will increase the frequency more, take a data point, and we'll continue to increase the frequency (120 Hz), and so on. You can see the graph beginning to dip slightly. Continue to increase the frequency. It's 2 kHz, and you can see the response of the filter starts to drop off.